Hello and welcome to the iSystem webinar series. Today's episode, the next to last in 2020, is about non-intrusive on-target software test without code instrumentation with iSystem tools. You will learn how to increase the quality of your software by using the iSystem test tool called testIDEA. testIDEA itself is included in every new debugger or maintenance purchase. My name is Sabrina Kisslinger. I'm the moderator. Today's speaker is Aleš Kožija, who will lead you through the technical presentation. Aleš is field application engineer at iSystem and is responsible for customer support and training. In his previous engagements, he worked as an embedded software developer, developing CPU applications and automated testing using C, C++, MATLAB, C#, and Python. Before we start, I would like to give you some general information. During the webinar, you will be muted. If you have questions, please use the question tab in the menu bar. Below the question tab, the handout tab allows you to download the presentation. Today's episode will be recorded and published on the iSystem YouTube channel. At the end of the webinar, some of your questions will be picked and answered by Aleš. All others will be answered by email afterwards. So that's it from my side. Let's start. Over to you, Aleš.
Thanks, Sabrina, for the introduction. Welcome to our webinar. I will be presenting on-target non-intrusive testing. After this webinar, you will be able to know how to prepare on-target non-intrusive testing, inject fault during a unit test. You will know how to prepare stubs, measure coverage, prepare test reporting, and how to generate a JUnit Python script for the continuous integration with Jenkins. Let's check what is the agenda for the webinar. First on agenda is presentation of the components of the on-target test setup. I will explain how the non-intrusive on-target testing works. After the testIDEA introduction, I will switch to live demo. I will start with a simple unit test. Later, I will demonstrate an example of fault injection and stubbing. Then I will use Trace Analyzer for the coverage measurement. After that, I will create a test report. At the end, I will generate from testIDEA a Python test script that is prepared for continuous integration with Jenkins. Let's start. Today, most of embedded applications are tested on the host PC. Either embedded application is executed on host PC or on the CPU simulator running on a PC. I will present on-target testing. Test will be executed on target MCU that is part of target ECU. Test will be executed on the binary code level. The test setup comprises of iSystem debugger, target ECU, and host PC. In our case, a debugger is an IC5700 debugger. The debugger is connected over Ethernet or USB connection to the host PC. The target MCU is connected over debug and optionally over the trace cable to the debugger. iSystem also provides additional hardware, analog digital I/O and CAN-LIN add-on modules. They are connected to the iSystem 5700 debugger. These modules could be used for generation of test digital and analog signals, CAN and LIN test messages. Add-on modules can be used for recording analog digital signals and for recording traffic on CAN and LIN buses. This can be executed with a testIDEA and scripting. On the picture is an example of the IC5700 that is connected together with the add-on module, analog to digital add-on module. testIDEA and scripts run on the host PC. Test specification file that describes the test suite is edited by the testIDEA. The iSystem Connect API is used to control winIDEA debug IDE and the debugger. The winIDEA contains the settings of the hardware configuration for the debugger and target CPU. testIDEA fully controls the debugger and executes tests on the target MCU. testIDEA is a test application provided with the iSystem debug tools. You can create black and white box testing. You don't need to add any instrumentation to your application, and you don't need to add any test drivers. You don't need to recompile application before the testing. testIDEA can include additional external Python scripts and modules. This can be added to the test execution. With these Python modules, you can add control to another hardware test equipment needed for the testing. You can prepare unit or system testing with testIDEA. By unit testing, you test a single function. Unit tests can be done with the use of testIDEA or script or both. The other class of testing are integration or system tests. System testing can be done with the testIDEA and scripts. Complex system tests are usually tested with the test scripts only. Before starting with the unit testing, you need to initialize the application on the target MCU. Necessary condition is that stack memory must be initialized. Optional, also MCU peripherals could be initialized, for instance, clocks, I/O ports, and so on. The code under test must be operational on the target system. An example of test initialization would be application binary download to a target memory and execution of an embedded application until a main function or until the hardware drivers are initialized. Before the execution of unit test, a debugger prepares so-called call stack on the stack memory. A function call for the function under test is prepared on the stack memory and function attributes are pushed to the stack. The debugger starts execution of function with a call from the stack and the embedded software starts running until the function returns. After test execution, testIDEA evaluates return values and other test values written on the CPU memories. Previous target state is restored, but testIDEA doesn't restore values on the global variables and values of the special function registers. The tester who prepares testing with the testIDEA needs to take care of the initialization of these values before each unit testing. System testing is a usual execution of an embedded application. The system tests start at a certain user-defined start point of an application execution when the test vector values are initialized. System test executes embedded application until the stop point. Then, at the stop point, the test results are verified. Now I will start with a live demonstration. For the first unit test, I will use a function called max. Function max takes two input attributes a and b and returns the value of the bigger one. So let's switch to winIDEA. winIDEA contains all settings for the test setup, so I can check whether the test setup works. Okay, I flashed the file, the binary, it runs. So the next step will be starting the testIDEA. testIDEA it started by clicking on the test from the main winIDEA menu and launch the testIDEA. Now the testIDEA is opened. First, I will prepare the settings of the testIDEA project. I will link this testIDEA project to a winIDEA settings. Then I will prepare the initialization. So the initialization should be first I will download the symbols only because the binary has already been flashed. I will always run this initialization sequence before each test start. Then I will run until the main function. So the stack, it's initialized at that point. I will save it, close it. I will save this. Okay, I will save as new project. Let's say the name demo number 5. So the next thing will be that I'll also prepare the initialization settings. I don't need to use multi-core because this CPU is not a multi-core. I will prepare the timeout. Let's say this is the maximum timeout for the execution of each test. I want control the stack this time, and this is basically, I think, okay for the first time. I will save, and then I will start with the first unit test. Okay, I need to download the debug symbols. The testIDEA is connected. Then I will prepare the first test on the function max. You see the function prototype, so I can type directly integers for the simplest test. And for the expected value, I will use 33. Okay, I can finish. Now I have created the first test. I can add the ID. Let's say the test ID will be number 1. I can use for the metadata description of the requirements. I can link the test ID with the testing of requirements. But let's say for the demonstration purposes, we don't want to bother with this. So the function it's prepared. It's function called maximum. There are 2 inputs and the expected value is 33. I will save all these settings and I will start the first test. So the test is running. Let's see. And it was finished with success. So we see we ended with on the main. For the second unit test, I will use a function called maximum power get. This function takes for the inputs 2 pointers to a structure engine. The structure engine contains the value maximum power, and this function maximum power get will return the value of the biggest maximum power of these 2 structures. Before jumping into the testIDEA demonstration, I would like to point it out that the testIDEA prepared for each unit test so-called call stack, and the test variables are pushed to the stack before the function is actually called. So in the case that we will use the same name as it is inside the function prototype, then this will make a confusion. This will make 2 sets. One is for the test set of the test variables, and another is for the local variables that are part of the input attributes. So we need to always use different names for the test variables than they are defined at the function prototype. I will create a new unit test on the function maximum power get. Here we see the prototype. I will create 2 sets of the structure and I will pass addresses like engine test 1 and address of the second test structure engine test 2. Okay, for time being I will finish the creation. I will add the ID of the test. I can use this for, also a structure, but let's say a sequence that automatically added by the testIDEA, and I need to define the test variables. So engine test and a structure is type of engine, and another test structure too, it's also type engine. Then I need to initialize them. I will use this button gene type 1. This will expand the structure for all elements, so I can easily add the initialization values. So here for the maximum power I will get the value 77,000 watts, and I need to do the same for the second structure. Okay, so the second structure will have ID number 2 and the maximum power will be 66,000. 66,000 watts. I need to save this value, so the expected is 77,000. Is the biggest, it's bigger value of those two. Okay, so I will run just this test, just select this test for the run, and we'll see it's okay. The test passed. The structure returned 77,000. Okay. For the third test, I will prepare the test that will fail. This time I will use a function called maximum power get back. It has the wrong condition inside the if statement. It is similar as the previous function maximum power get, but this function with the back will have will return the smaller one because the if condition is wrong. So let's jump into the test idea. Here I will need to prepare another test, but I will use a trick here. I pre-prepared this test that will fail, and I will just copy it. So I copy it from the another file, from test specification file, and I will paste it. Okay, I need to click here and paste it. Okay, so this function will fail. I need to prepare the ID of the test, so I will use this guy. Then the function, it's with a back. It uses the same two pointers to a structure, and this time I prepare a pointers to a structure. So these are structures and pointers, and the structure contains the similar values 77,000 and 66,000. And this time expected is also the same 77,000, but the function, because it has bug, will fail. The test will fail. So let's run the test. Also, okay, and we see that the test failed. Yeah. And what we can do now? We can start testIDEA with the debug mode. This will bring us focus into, it will stop the execution at the beginning of the function, and it will bring the focus to winIDEA debug IDE, and we can immediately start with debugging. So let's do that. I started testIDEA with the debug mode. Immediately after the function is called with the test vector, the execution is stopped, and we can then step through the function and see that this condition is wrong. Okay, we see it stopped here, and we see the test vector is correct. It should return this one, but and then we can check the if condition. We can see that here lies the bug. So this is a technique how to debug, how to use this idea for the test generation of the test vector, and how to start debugging with the winIDEA. For the next unit test, I will demonstrate the usage of the stubs. So what is a stub? A stub is a piece of code that is used instead of some other program functionality. This may be used as a substitute for the non-existing code. It can simulate the functionality that is not actually implemented. So the use cases are the functionality, certain functionality is not implemented yet. We need to simulate this behavior with a stub. Required hardware, it's not available. For instance, if we need external hardware, for instance, for the measurement of the temperature, we don't have it. We just stop the readouts. In the case that we want to accelerate the test, for instance, if we have temperature and the hardware, we need to heat up and to cool down to get the different readouts of the temperature. We can simply stop it and accelerate the testing. And in the case that we want to make this deterministic to get rid of sensor noise, we can again use stubs. So for the stub example, I will use a function called temperature read. This function calls some function called temperature sensor read. This will actually read out a temperature out of the sensor, temperature sensor. We don't have it, so we will use stub instead of temperature sensor read function. This function also uses the global variable GAlarm. GAlarm is set, rise the alarm if the temperature is too high. In the case the temperature is above 99, this will rise alarm. So let's jump to testIDEA. So inside the testIDEA, I will create a new test that will use a temperature read. Okay. So I can use instead of sensor just an integer, and I will finish. Then I need to initialize the global variable G alarm. It's already part of the system. It's defined. It's we have the debugger has debug symbol information, so it knows at what exact location this is located, and we will initialize alarm with a 0. The next step will be we will use and create a stub. We can use a wizard. We see the temperature read calls the temperature sensor read, and we can create a stub there. Okay, so we can immediately jump with this button into winIDEA so that we can see the function, this function that will be stubbed, actually always return 88 for the temperature. I return back to testIDEA. I can automatically define the call attribute, it's AD. I will define the stub return value, stub return. This value will be used to pass to simulate the return values of the readouts. This should be called once at least. And now I will assign and prepare the stub return value. Stub return value will return, we will with the stub return 77 instead of 88. So we have this prepared, and we need to prepare the expected value. For the expected value we can use the C expressions. For instance, now this will return value 77. The temperature read, I will use the brackets because I will add another condition for the G alarm. G alarm should be equal 0 because the temperature 77 is smaller than 99, and this shouldn't rise an alarm. So I need also to add the metadata, the information of this unit test. So I think I prepared that. Okay, value, I can jump and see how it looks, the temperature. Here I have it, the temperature. The G alarm will be raised, so this will return 77. It will be smaller, so sorry, the G alarm won't be raised, and the temperature read will only return the value 77. So let's jump back to. So I think I prepared everything. We can run the test number 4 that use stubs. Okay, everything went smoothly. So the stub was calls 1, it returned value 77, the alarm was 0, and the return value was 77. So my next step will be that I will enable also the coverage measurement. The coverage measurement uses the trace feature of the CPU. This CPU has trace capabilities. We can use it. The winIDEA has so-called iSystem Trace Analyzer, and we will enable this analyzer. We need to define a trace document file. For the naming of trace document file, I will use the testID. This will bring the testID value, so I can easily link the trace document that will be saved to this unit test. So I will save the trace document file at the end of the test, and I will close it. In the case that the CPU wouldn't have trace capabilities, we can use so-called feature slow run. In this case, the execution won't be real-time anymore. The debugger will step through the code and record what statement, what instruction has been executed, what branch has been taken, and it will construct and build the coverage measurement report. So in our case, we will use trace feature because we have it. And once again, I will create a coverage measurement report. I will use multi functional document, HTML document. I will measure assemblers. Trace document can measure binary on the coverage on the binary level, so I can get assembler information, the C source information, the function lines, and the assembler information. All this will be collected with and measured with the coverage, and the next step will be I can create a coverage measurement on the different scales. Since only temperature read function will be called, I will enable coverage measurement there. The temperature sensor read function will be stopped, so I cannot, I mean, it's pointless to measure coverage there because this part of code won't be executed. So, okay, and I can also define the level of the coverage measurement. The percentage should be at least 40 for the object code level and for the source also. And if this won't be measured with a test, this test will fail because of these conditions here. So I hope everything I configured well. I will rerun the test once again. I will use stub and the coverage measurement in this test run. So soon we'll get the results and hopefully everything went smoothly. Yes, we measured the coverage. The percentage is 70 and 75. We created this document file. The expected value is as we prepared. So the test passed. With the next unit test, I will present derived tests. So what are the derived tests? The derived tests are kind of tests organized in hierarchy. The parent, the top unit test, will contain all the description for the testing, all the feature of the unit test. And the child, the derived test, can inherit some sections of the base test or it can override. So basically we will kind of copy the parent test and then quickly change some things and we will get a different test. Okay, so let's go to the next slide. This is once again our next our function of the test, temperature read. What I will change the return value of the stub function, temperature sensor read. The stub return will be 100 so that the G alarm will be raised. And this accordingly I need to change the expected values. So let's go to the testIDEA. inside the testIDEA, I will select the parent test temperature read, and I will generate a derived test. So I will select the same function for the, and I will just finish it. So I have this derived test. I will change the ID of it. So I clear the inheritance, then I'll go to stub. Okay. The stub value shouldn't be inherited completely. I will change the stub return value. So the stub will return 100. And then I'll go to expected. The expected value should be 100. Okay, 100. And the G-alarm should be equal to 1. Okay, so this is what, now I have a new test that will test the else, the other part of the if condition. And the coverage measurement is the same. The basic stub description is the same, just the stub return values are different. We can see if I select both unit test in the table view, what is the difference and what is the equal. We see here the stub value is different between the parent and derived test, and the expected values are different. Okay, let's run the test. So now once again the parent test is first executed. The coverage will be measured also for it, and now the second test has started, and both finished successfully. I will go to forum view back. So the statistics for the parent test is like this, and the coverage measurement statistic for the second, you see the percentage are different because the other part of the function code has been executed. The stubs have been, and this value was returned. Okay, so this is about derived test, and I can generate more derived test and test also the other border values, etc., easily with the function, with the derived feature. Now I will present test points. The test points are basically breakpoints that are set inside the program location. So the testIDEA stops the execution. At that point we can verify the local and global variables. We can assign values to local and global variables. This is used for the fault injection. We can log the variable values. We can run scripts. So I will use for the demonstration, I will use function called allTemperatureRead. This function allTemperatureRead in for loop calls 5 times temperature read function. Instead of stubbing of this function, I will stop execution this line and I will change temperature. So once will be below 100 and several times will be above the 100. So I'll get both the true and the false condition for the if statement. And I will also measure the coverage. So let's go to testIDEA. I have already prepared this test and I will just copy it. That'll be faster than typing, and I will explain all the features. So I will copy from one test specification, and then I'll go to my here and I will paste the, okay, it doesn't want, I need to click inside. So this time it works. So I will change the meta data, so the test is number 5. The function is allTemperatureRead. It uses the engine structure, so this is defined here, the pointer to engine. Then expected values With this test I will raise an alarm, I will have false. Okay, the value will be 0. Then inside the test point. So the test point I created for the injection. At the fault injection I will have a table for the for loop. At the first time when this will be hit, I expect it to be hit 5 times. The temperature will be changed, the local variable temp will be changed to 66, then 77, and the last time will be 102. This will cause the alarm to be raised. So the location of the test point is inside the function temperature read, and it search for the line of the if statement. We can go and see where this is located inside the source code. So here will be set a breakpoint for each for loop. So let's go back. Now we are back. So okay, and I will also measure coverage. This will work. I will save. So let's start the test. Okay, temperature read will be executed. This will stop 5 times and measure the coverage, so the test execution will be a bit longer. Still, the test is still running. Okay, and the execution finished successfully. The test passed, so we see each of the hit for the test value has been used. The expected value are okay, and the statistics for the functions are there with the coverage measurement. Grouping of tests can be used to prepare different test scenarios. For instance, we can prepare a specific group for tests on the modules. Then we can just run these tests that use the test of the functions that are member of this specific module. We can prepare a test group that just execute the tests that measure coverage, for instance, and then we can, on this group, create merge coverage report. So let's go to testIDEA and we'll see how to use grouping. So first I added for each test that use coverage measurement, I've added the tag with the name coverage tag. This tag I will use later to prepare a subgroup that will execute only the test with the coverage measurement. First, I will create a top group that will filter out from all of the tests just the members of the demo module. And because all the functions that are inside the system uses the functions of the demo modules, basically all the tests are part of this group. I'm always using filters to add the members of the group, so I can use the binary file, I can use specific functions, I can add and list specific IDs of the tests to create a specific group. Then I will create out of this group a subgroup that will be used for the coverage measurement. So let's say this will be group number 2. And the group will filter out and will use for the members all the tests from the group that use the coverage tag. Okay, so I specified a specific subgroup, and here I will enable the combined merge of the coverage. So I'll get a coverage report on this scope. I will add the trace document file that will contain the merged coverage measurement, and then I will create also the report. And I will use multifunctional, and I will select the measurement items, and now we prepare the testing for the coverage Okay, let's run every test from the system. And it's important to, for selection of the groups and subgroups, we have to use filtering. If we, for instance, want to remove the member of the group, we shouldn't delete directly the specific test with the ID out, because then this test will be completely removed out of the testIDEA list of all tests. So we see the testing is progressing. Now the last test is running and only the third test failed. That is expected because the function max power get has a bug. So let's wait a couple minutes to test to finish, and then I will comment the report of the group's results too. So now the group results are preparing the merge coverage for the second group. So this will take a little bit of time and it's finished. So if I go to first group, we can see the function statistics. We see the members of this module and we see that only few functions have been tested. So we see where to put the future test effort because we need to test also the other functions. And for the second test, we can also see the reports, what test function have been tested and measured with the coverage. And here we have also the combined statistics, how many tests and percentage of the function have been tested. And we can see also the coverage result. These are the merge coverage results on the scope of demo module. Now we will prepare the test report. The test report supports the different formats like XML, YAML, comma separated value, and Excel files. In the preparation for the saving test report, we can define the different styles, the names, we can define who was the tester, the revision, SVN, and so on. So let's go to demonstration. So after finishing the test with the grouping, we can now prepare the test report. So I'll go and we can select the styles of report. We prepared those styles in advance. We will create a HTML file. This is the name of the report file. It should be report, in my case, report file XML, and we can immediately open a browser. Here I added also the tester date, SVN revision number, and so on. So let's create a test. We create a test report. This will be open in the browser. So here we see how many tests failed. Okay, we see the coverage report. We can click on the HTML document and we can see the test on the demo file. We can click on the specific function. We see what line have been tested and which one not, which branch has been taken, for instance here, and this branch hasn't been taken. If I go back to report, okay, so inside report I see the group reporting on the demo module scope, so I see which function has passed and which one was failed and how many tests were there and so on. Okay, for instance, also I added for the test point usage test also the logging before I inject false, what was before and after. You know, the function returned always the 88 centigrade Celsius, but I injected false with the last one, 202. So basically this is a short about the reporting. Creating Python script will be the last topic covered with the webinar. So the testIDEA internally has a Python script generator. It uses iSystem Connect and iSystem Test API to control winIDEA and the BlueBox and the target. So it will use test specification defined and created with the testIDEA and will directly create a script that will run the same test as defined inside the testIDEA. So let's go to demonstration. Inside testIDEA, I will open iTools from the main menu and I will open generate test script. Here I will define the name of the test script. It will be, let's say, demo waypoint number 1. It will use the test specification and it will create a test report for the JUnit format. It will export coverage from Jenkins and the report will be opened with the browser. Okay, so now I will generate and create the test script. I will go to winIDEA and then there I will open and run the script. Inside the winIDEA, I will open a Python file that was just created. It was a demo web 1 Python script and I can run it inside. I have tools and I can run it inside the winIDEA. So I will run the script. This script will perform exactly the same test as testIDEA and you can see in the background how the script controls the winIDEA and how now to measure coverage and execute each test. The same list of the tests and the same reporting will be generated as it was when we run the testIDEA test out from the testIDEA. Soon will be the end of testing. Now the test number 5 is executing. So there will be a creation of the merge coverage at the end. This will take a little bit of time. So okay, so now the merge coverage is generated and at the end a test report will be opened in a browser. So we need to wait a little bit. Okay, the report is open, so we see the script perform and executed exactly the same test and reports and generated the same report as a testIDEA. So I'm finishing and I finished my presentation and demonstration and hopefully you enjoy it. Now I will be open for the questions. Sabina, can you take it over, please?
Thank you, Aleš, for your demonstration. So, as you said, let's continue with the Q&A session. A lot of questions reached us, and the first one is, where can I get information if my CPU is supported for testing with testIDEA?
This information can be get from our webpage. Our webpage describes what CPU families and CPU variants are supported, and basically for each CPU that is supported for the debugging, you can also run testIDEA. In the case that you cannot find from our documentation on the web and you wouldn't be certain if your specific CPU is supported, you can send email to me or to sales or to support and we will help you to figure out.
In general, testIDEA is included in every new debugger or maintenance renewal purchase, so this may also be helpful for you. The next question, can testIDEA generate test vectors for unit testing?
Yes, that's also possible. The testIDEA has a test vector generation tool. It's you need to add how many tests you want to have, what are the border values, and then generator generates those test vectors, those values in between. It doesn't use kind of artificial intelligence, so sometimes you need to correct to get really specific test vector. But yes, you can generate test vector out of testIDEA.
Thanks, Aleš. Let's come to the next one. When running in debug mode, does testIDEA also inject faults and use stubs?
Yes, it does. When in debug mode, you can run until to the beginning, then you need to put another breakpoint after the stubbing, fault injection, and you go into testIDEA and continue running, and then you get also the stubs and test points. So the stubs are basically also controlled with debugger. I didn't mention during the presentation this. For the stub function, the debugger stop execution before the function is called, and then actually prepare the return values and the side effects and execute the code as the function would be called. Yeah. Okay. Yes, and this can be used for debugging too. Yeah.
And we have another question on stubs. Is it possible to use stubs if we have stubs in the condition?
Yes, because the testIDEA will recognize that let's say the parent function calls sub functions, and then you can go into table and you could say, yes, I want that this sub function call and sub function should be stubbed, and the testIDEA will prepare the stub. Yes, it is possible.
Thanks, Alesh. I have another one. If the function is not called from main, what do we need to do?
You need to compile that way that, for instance, for the function that it's never used inside the main and other functions, you need to compile that way that the linker wouldn't remove this function to be tested. That's probably a compile and link switch there for the build tool. But if the linker optimize and remove the function that are not called, then you cannot test it. It must be compiled and part of the binary file. Debugger needs a actual debug symbol, and the binary should contain somewhere the executable code.
I guess we can also talk about this later offline. So if it was not clear enough, let's go to the next one. Is it possible to check specific module registers after they were initialized? The goal is to check if the initialization results in the expected configuration.
Just test the initialization. If you initialize several modules and several registers, then it's basically, I would suggest to go to system test. With the system test, you run until this initialization is stopped. And then you actually, at the stop point, you can access whatever variable, register, and so on. And you can check whether this is initialized or not. If you want to check whether a certain function, initialized function, was called, then I would suggest you could use coverage measurement. With the coverage, you can get if the certain function was called and executed, then there should be a coverage measurement results bigger than 0, for instance. Hopefully, I understand correctly your question, because it's actually could be quite differently understood, yes. But if I didn't respond it well, just please send me email.
Okay, we need to come to an end. All questions which were not answered now will be answered, of course, by email shortly. And before you leave, I would like to give you some additional information. Do not forget to download the presentation in the handout tab of the menu bar. Check out our free online testIDEA tutorial, our YouTube channel where this webinar will be hosted, and others are already available. And if you want to, feel free to register for our newsletter to get interesting updates automatically. If questions come to your mind later, feel free to send an email to webinar@isystem.com or your dedicated iSystem contact person. Thanks for attending, and please fill in the feedback form after leaving. Bye and take care.